Hey, thank you for invitation for today's session. My name is Jun Yamaguchi from Kawasaki Heavy Industries from Japan, and I'm in charge of the collaboration development for the new business development. Uh, Personally, I think today's selection for the speakers is very good because we started a discussion from the silicon level from the i3 for TSMC, and after that we step up to the chips or controller devices, and after that to the environment for the development. For now, I'd like to share my information about the social implementation for robots. Before that, I'd like to introduce my Kawasaki briefly, and after that, we introduce our initiatives for social robots. And after that, this is a core part for the third point is robotics sophisticated by AI. And after that, we'd like to introduce some collaboration space in Japan, Kawaruba. As you know, we Kawasaki provide a wide variety of products for sea or land or air. And I hope many people enjoy the Kawasaki's motorcycle in your house, hopefully. And in Kawasaki, we have the 40,000 people in the work all over the world, and we have over the 100 subsidiaries in the world. And that's that we have a wide variety of income from the airplane, or rolling stocks, or robots, or ships. It changes the year by year because it drastically changes the economics, world economics changes. And also, we also have the subsidiaries all over the world. Of course, we have the subsidiaries in Taiwan mainly for robotics. And we established the three types of the group vision. One is a safe and secure remotely connected society. The second is near future mobility and energy and environmental solutions. The first two things is a very deep relationship with social robots, I think. Okay, let's go on to the deep dive into the social robot initiatives. Let's track to our initiatives. Maybe some people know Kawasaki started the industrial robot business from over 50 years ago. And after that, we promote to provide our robots into the automotive sectors. And after that, we enhance our promotion to the semiconductor system. And recently, we step out from the factory for the robot, mainly for the telesurgery system or human robot. Okay, let's go on to the recently activities in Kawasaki in these 15 years. Firstly, we started to take into the cutting-edge technologies into the robotics. For example, the second era is robot plus network. That means robot can be operated remotely. That means a robot is not machine, is a remote worker. The third era is a robot plus network plus AI, as we discussed today, and that can be determine the robotics itself and communicate with a human by robot. So we call that the robot can be assistant. It's not machine. The fourth era is a robot plus network plus AI plus agent. They can decide their behavior by themselves. That means a robot is as a companion. In this later, I will show you some small video for each cases. First of all, I'd like to show you the robot plus network. That means a remote operation. This is a painting work in the factory to save the workers for dangerous work because the ingredient is very hard, very harmless. And this case is a grinding. The grinding machine is, as you know, very heavy and very noisy and very dangerous. So the people can operate some small controller to make a grind. And to such kind of operation applied to the telesurgery system. And we conducted the long-distance teleoperating from Singapore to Japan, maybe 5,000 kilometers. This is a remote control of the robots. The second is robot plus network plus AI. As you know, the robot can communicate with human. And we already implement this kind of the robot into the Japanese hospital for a few years. And today, we Kawasaki have the booth over there, and we exhibit these types of robot in the hospital. This is a delivery robot in the hospital. The second case is left side is a communication robot. We call that a gnocchi. And we're trying to the nursing care home to save the worker in the nursing care home. Instead of the staff, the gnocchi can communicate with the nursing caretaker. Of course, the gnocchi can speak by themselves by using of the ChatGPT or such kind of LLM. But in this case, we use that gnocchi as a telecommunicator for such kind of Microsoft Teams. Instead of the actual human, the remote side people can connect to the patient. And the next generation is a robot plus network plus AI plus agent. We have the two types of human robot. One is a Kaleid, is a powerful type, and the second is a Friends. It's a very friendly type. The Kaleid is planned for the works with a human, especially for the hard site, such kind of a disaster place to rescue. In this demonstration, the Kaleid can move by themselves and communicate with a human to support people. Especially in Japan, we can find many natural disasters in these years. So the government needs for this type of technologies to avoid or to rescue the people from the disaster's place. The left side is Friends, and that means support the nursing care or hospital in the hospital. So, but it's not powerful. So, but they can carry the wheelchairs in the hospital, and of course communicate with the patient. It's fine. Let's go to the outside of the hospital. That's okay. That's it. That's very easy. But at this moment, this is not allowed in the law, in Japanese law. So we Kawasaki are collaborating with the Japanese government to change the law to use these types of the solution. As some guys shows this similar statistics, social robot were not so many robots in our society, but Gartner's reports, the CAGR of social robot is very steeper, over the 30%. It's very promising market, and the marketplace is Asia area. It's not so big, but a very high growth. We think so. We like to make some market and business in Asia area with your company. Actually, in Kawasaki, we have some requests from other companies to use the social robots, some inspection or guidance or rescue for each companies, mainly for the social infrastructure companies. Until now, we, Kawasaki, collaborate with other companies to enhance the robot's function. After that, in the future, what is next? The robots can help us, and we can do that more things with a robot. This is the concept of video, the Coreo. That's a combination with a motorcycle and robots. You can find this type of robot in the Osaka Expo in this year. And maybe in this December, we have exhibited this types of robot in the IREX in Tokyo. You can find these types of robot. That's our trajectory for the social robot trials. And after that, from now, I'd like to step into the AI. As some guys mentioned that the social robot is different from the industrial robot because industrial robot needs efficiency and repeatability, but social robot is flexibility and robustness because there are different types of requirement from the human or people. That's very different from in the factory. To react to that, many types of the technology we need, mainly for intelligence represented by AI, or the communication with a human represented by conversation with a human. And the left down side is a sensing. Sensing means catch the situation for around the robot, because robot can move over there, so that's very mandatory to catch the sensing the circumstances. In that, intelligence, communication, and sensing as established from the AI, I think. So the sensing, as we would like to start from the visual AI. Regarding the intelligence, we use the knowledges. And for the communication, we start from the conversation. But all the AI is respectively developing not only by Kawasaki. It's already on the shelf or in the market or has developed by other companies. So we collaborate with such kind of a company to make that. And finally, the left downside is the motion generation. That means embodied AI or physical AI. That's very important for the actual robot, but it's easy to say, but hard to create that. In that case, we like to collaborate with your company to create that. And for the embodied AI, someone says, and that's the same thing. And the cerebrum and the cerebellum as intelligence or as reflexes. And these types of thought put into the robotics controller, we use that some core layers for robot controller. But it's just a concept, and we, Kawasaki, are trying to establish these types of layer infrastructure, and we will deliver these types of information to other robot companies. And so it will be very helpful for other companies to collaborate with the same layer, communicate with on the same modules, software modules. By using that, we, Kawasaki, already tried to some AI application for actual social robot. The left side is in the worker in the bin picking or recycle factory. The blue where people is sorting the many colors, many types of the bin, and robot allowed support that by visual AI. The right side is a very tight clearance assembly line. It's very depends on the feeling of the touching. It's very hard to create the AI, but we take the data from the remote operating system and train the AI by using the data, and we go to the automation. The bottom side is a conversation, as I explained before. This is just a sample for the tight clearance automation, assembly automation. The left side people operating some controller for the remote operating for the robots, and it's very hard clearance to assemble manually. It's very hard to make a software for a robot. In that case, we utilize the data from the remote operating and to make some AI by using the learning for the AI. But these types of operation is we don't have to ask the operator so many times. So we like to use the imitation learning to use the small size of the data. It's succeeded for this is a movie is operating by AI. Of course, we are trying to the small cerebellum training because, as you know, that this is a Isaac Lab of NVIDIA. It's mandatory for the robustness for the social robots. And from until now, we talk about a single robot, single operation. But in the future, many types of robots, not only by Kawasaki, different types of different vendors of robot will collaborate with in our society. For that, we like to have some public infrastructure. We are building that as a cloud system. As we call that a social robot platform. As you know, there are so many platforms in our society, but there are no competitor, I think. And that's a potential collaboration partner for the collaborate with other platforms, exchange data or knowledges, because for more helpful and for more safety and for more vendors. And that means a total solution for with other types of vendors for us to save our future. And not only the technical side, but also we are trying to discuss with the Japanese government how to use the data for gathered from the robots. Because on the cloud, data on the cloud is used for the different company, AI developer. So that means data across the board. So we like to ask the Japanese government to make some rules or guidelines between the other companies, other countries. So we are discussing with internal Japanese government, and in this Japanese government, we submit some AI white paper into the Japanese cabinet. So we are stepping into the new phase to create a new AI nationally. But Japan is a small country, so we like to connect with other countries, especially for Asia, to make some basic economic range in the Asia. So exchange the data, knowledges, or human resources inside the Asia to deliver such kind of outcome to the world. That's our vision. But the most important thing is safety, as you said. And we think two types of safety we have. One is physical safety. The second is psychological safety. Physical safety means the robot itself, the behavior, softness contact or falling safety, or interaction, ensuring clearance from other items, so touching. The second is psychological safety is easy to understand behavior because the robot cannot be control the difference move from the human. It's very terrible. So we have to take care of such kind of aspect. The second is no unexpected behaviors. It's very dangerous, as you can understand. Yeah. This kind of program statement will be set up to implement physical and psychological safety, complex recognition and behavior generation is mandatory, I think. To that, AI technology is very helpful to develop them efficiently. But AI is not perfect at this moment. So mistakes of AI make physical accident or psychological anxiety. Or generative AI can make flexible decisions. It's very good, but it might generate unpredictable behavior. That's a problem, I think. In that case, for robot to be implemented in society, it should be guaranteed that AI decisions are safe. And safety assessment and standards for AI should be defined to form guidelines, hopefully from Asia. So I would say, why don't you take these initiatives and expand it from Asia to the world, centered on Taiwan and Japan? That's my proposal. And Kawasaki is already a member of Japanese consortiums to discuss about them. This is just a concept. As a team, let's expand an unprecedented lifestyle from Asia to the world with robots. That era is just around the corner. It's great progress to share this innovative vision with everyone today. I believe this vision can be realized by collaborating with your companies all over these rooms. We named that the collaboration name ABA. A, advanced operation with digital intelligence. B, business innovation origin from Asia. A, augmentation and transformation of Asia economy. That's our concept for the collaboration in Asia. Okay, this is additional information from Kawasaki. It's our co-creation space called Kawaruba. We established this co-creation space near the Haneda Airport, International Airport in Tokyo. And that space is used not only by Kawasaki, ANA or Denso or Iwatani is that's the space. And each sector has an innovative power. So we collaborate with other companies like ANA or Denso to create a new innovation. In Kawaruba, we set up the 5 problem statements: remote society and low birth rate and aging population, and pandemics and disasters, and global environment and energy. In this problem statements, robotics changes. Initially, the left 3 problems. And in Kawaruba, we set up the business themes, 2 types of business theme. One is blue side is hydrogen and carbon neutral. It's energy. The right side is our initiatives, social robots. Regarding the social robot, we are trying to in Kawaruba, the first floor, we develop the robots itself. And second floor, we explore the application for the social robot with partners and company and other academias. And after that, we implement the society. That means make a business. That's our stream or social implementation, so social robots. This is just a picture for the first floor lab. It's separated for the security and safety. Each types of the rooms should be used for the different academia or partners, companies with Kawasaki. The second floor is we use such kind of the robots, bringing into the co-creation space and to make some set up the physical simulation space to verify the usage of the social robots. For example, the situation is hospitals or cafes, indoor side, and the outside side is right side is a public area, such kind of parks or outside of the system. Or the other side is disaster sites. That means to rescue the people from the dangerous states. Okay, we can challenge at Kawaruba with your companies. That's well-being society with robots is coming soon. We have to prepare for that for our children and grandchildren. Okay, thank you. Let's enjoy the future world with a social robot with Kawasaki. Thank you so much.